Hello everyone, my name is Kanaya Green, and in today's video I will be discussing Sir Isaac Newton and his groundbreaking contribution to physics. This video will explore his personal background, Newton's three laws of motion, and how his theories have impacted contemporary society. First, let's start with an overview of Sir Isaac Newton's early life and significant achievements. Sir Isaac Newton was born on January 4th, 1643 in Woolsthorpe, England. His parents were Hannah Ayscough and Isaac Newton Sr. From a young age, Sir Isaac Newton displayed a keen interest in the natural world, which led him to attend Trinity College, Cambridge. Among Newton's many contributions, one of his notable achievements was the development of the reflecting telescope. Unlike earlier telescopes that used lenses, Newton's design used a curved mirror to reflect light and form an image. This innovation significantly improved the quality of astronomical observations by solving the problem of chromatic aberration. The Newtonian telescope greatly enhanced the clarity of astronomical observations and allowed for more detailed studies of celestial objects. Furthermore, this innovation marked a major advancement in the field of optics, and it also contributed to the development of modern observational astronomy. One key feature surrounding Sir Isaac Newton is the apple story. The famous apple story is often associated with Newton's work on gravity. According to the legend, while Newton was sitting under an apple tree in his family orchard at the Woolsthorpe Manor, he observed an apple falling to the ground. Now, there is a debate in society that says that some argue that the apple fell on his head, while others say that he just observed it fall from the tree. This observation led him to question why apples fall straight down and not sideways or upward. And it was this discovery that sparked his thoughts about the force of gravity. Furthermore, this observation of the falling apple contributed to Newton's formulation of the law of universal gravitation. And this law states that every mass attracts every other mass with a force that is proportional to the product of their masses and inversely proportional to the square of the distance between their centers. Now we're going to go and explore Newton's three laws of motion, which are fundamental to classical mechanics and describe how objects move. These laws laid the groundwork for much of modern physics and engineering. First, we will divulge into the first law of motion, which is the law of inertia. Newton's first law, also known as the law of inertia, states that an object will remain at rest or continue moving at a constant velocity unless acted upon by an external force. This principle introduces the concepts of inertia, which is the resistance of an object to change in its state of motion. To provide an example of how the law of inertia works, if a book is lying on a table, it will stay there unless someone moves it. It is comparable to how a car will keep moving at a constant speed unless brakes or friction slow it down. And this is the most common referred to example when trying to provide an overview of the law of inertia. The second law of the three laws of motion is the law of acceleration. The second law states that the force acting on an object is equal to the mass of the object multiplied by its acceleration. The law of acceleration can be expressed in the equation of force equals mass times acceleration. And the F is force in newtons, and the M represents the mass in kilograms, and A is an acceleration in meters per second squared. An example of how the law of acceleration works is if you push a car, the harder you push, meaning the more force you apply, the faster it accelerates. A heavier car requires more force to accelerate at the same time as a lighter car. Now, the final law of the three laws of motion is the action-reaction law. The third law, known as the action-reaction law, states that for every action there is an equal and opposite reaction. To express this action-reaction law, it can be viewed as F times action equals negative X reaction Negative F reaction. To provide an example of the action-reaction law, when you jump off a diving board, the board pushes you upward with an equal force to force you exert downward. This principle explains why rockets can propel themselves into space. All of these three laws of motions have had a significant impact on scientific understanding, and having explored Newton's laws, let's now examine their impact on scientific understanding and how it has shaped society today. As we all know, Newton was a key figure in the scientific revolution, and his work in classical mechanics transformed our comprehension of the physical world. Newton's theories provided a unified framework for understanding both terrestrial and celestial mechanics, leading to significant advancements in science and technology. Sir Isaac Newton's work set the stage for future developments in physics and engineering. In today's society, Newton's laws of motions can be used in simulating car collisions and also navigating spacecraft. There is also presence of the laws of motions when basketball players are playing in their game. Some contrary views surrounding Sir Isaac Newton's laws was that before Newton's contributions, the dominant scientific views were based on Aristotle's ideas in Ptolemaic astronomy. Aristotle's philosophy described the universe in terms of circular orbits and perfect spheres. Newton's more precise and mathematical description of motion and gravity challenged these older models, leading to a more accurate understanding of the natural world. Newton's work replaced these outdated models with a framework that could accurately describe a wide range of physical phenomena, from falling apples to planetary orbits. Finally, let's discuss the current impact and value of Newton's laws. Sir Isaac Newton's principles remain fundamental in engineering and physics. They are crucial for designing vehicles, predicting satellite orbits, and optimizing sports performances. For example, Newton's laws are applied in automotive safety systems like crumple zones and airbags to protect passengers during collisions, and this can be seen in modern technology. His principles are used in space missions to calculate satellite trajectories and in various everyday technologies. Now that we have discussed everything, we have explored Sir Isaac Newton's background, his invention of the reflecting telescope, the iconic apple story, his three laws of motion that have contributed much to physics, and their continued relevance in contemporary science and technology. Newton's work laid the foundation for classical mechanics and continues to influence various fields today. Thank you for watching.